Hey guys, Mr. Bowman here. In this video, we are learning to apply something called TARSOG to help us analyze scatter plots. So before we get into the TARSOG part of it too much, just a reminder about scatter plots. They are graphs which measure and compare two number variables. So just a reminder what that might look like. We've got a y-axis and an x-axis. This here may be someone's height, which would be measured as a number in centimeters. And perhaps the other axis is someone's arm span, also a number that will be measured kind of in centimeters. So they're both going to be number variables. And what you can do is you can put a dot representing a person. Their height would be here and their arm span would be here. This person up here, their height would be down here and their arm span would be over there. So to help us analyze these graphs, TARSOG is the abbreviation that we can use to help us get some meaningful insights from these. Cleared all that working, TARSOG, as I said, the abbreviation we need to know. Let's quickly run through what each of them could be. So the T, that stands for trend. The A stands for something called association. The R stands for relationship. So some of these may be familiar to you already. The S, this is normally the newer one of the TARSOG, scatter. And we then have outliers, which I understand year 9s tend to be pretty comfortable with. And then finally, at the very end, we're going to have groupings. Starting off with the trend, you've got one of two options. Your trend line can have a linear relationship, or it could have a non-linear relationship. So just a reminder, a linear relationship, that is when your data looks like a straight line. And a non-linear relationship, these are other types of relationships. They could be exponential relationships, quadratics, maybe they look like parabolas, or maybe they've got something else going on. So I've got some visual examples up here. A linear relationship, when I drew a line at best fit on my data, I could see it largely looked like a straight line. But for my non-linear one, the data managed to go up and then it was going down. So perhaps a curved line was best for that. And that idea of a curved line is the best way to describe the non-linear relationships. The next one we're going to look at is association. And association, we have two options. The relationships can be described as positive or negative. And I've got another example set up. So here's the positive stuff. You can see all our data points here. If I drew a line of best fit, you can see our line of best fit would be going up. So what that means is when this variable increases along the x-axis, you would expect the variable on the y-axis to also increase it. So that's when the line is going up. And a negative relationship, well, that's the one going down. So you can see all of them. A line of best fit would certainly be going downwards. And what you can see is as we go across along the x-axis, we can see the other variable ends up decreasing. So negative relationships, the line of best fit is going downwards. On to the third one, the R of TARSOG, that stands for the relationship. Now this one here, there's a bit more background information I need to tell you about. So when we have our graph, and I'm drawing one down the bottom here, we'll have a line of best fit, which kind of surrounds our data points. And I'm just going to draw one point in here to show you what I mean. So this here is the data point here. So the difference between the data point and the line of best fit, we refer to that as residuals. And what these residuals do is they show us a little bit about the variation of your data. So if your data points are all very close to the line, there is going to be very small residuals. So there's an example. That's a very small residual, which means there won't be a lot of variation. So using the idea of residuals, we can then explore the relationship of a certain graph. And we can see here, let's start off with strong. And drawing a line of best fit, ignore the dotted lines for now, we can see the line of best fit would go roughly in the middle there. If you look at the residuals of this graph, and it's going to be difficult to see me drawing, but I've drawn something in there, you can see the residuals are very small, which means there are small amounts of variation. So that is what a strong relationship is. There are a small amount of residuals. The line of best fit is really, really close to your data. So that's the first one. It can be strong. The next one, weak data, if I had a line of best fit, it would kind of be floating around the middle there. And again, we can see by these dotted lines, some of the residuals, they're actually quite big. So some of the data points are actually quite far away from the line of best fit. And that means there's high amounts of variation in that data set. And that would be an example of a weak relationship. And there are some data sets that are going to be in the middle. When you get data sets like that, you can describe them using the word moderate. And in time, you might end up being stuck between them, and you might say, well, it's moderately strong, or conversely, you might say it's moderately weak if you think it's between them. And now on to scatter, and as I said before, scatter is probably the new one for us. And geez, I'm getting a bit cramped for working here. So our scatter can be constant, and I'll explain what that means, or it could be non-constant. And the idea of scatter, it relates heavily to the residuals / the variation that we looked at for the relationship. So looking at this example, so the first example is to do with constant. And again, if I sketch my line of best fit, I can see that the residual here is roughly the same as the residual here, which is roughly the residual here. So you can see the residuals tend to be the same amount no matter where they are on the graph. So basically they've got consistent or constant residuals is how I like to describe it. If we move on over to the non-constant version, if I drew a line of best fit, it would go a little bit like this. We can see the residuals at the bottom compared with the residuals at the top. They are vastly different to each other. So that is an example of non-constant residuals or non-constant variation. So the variation is much bigger up here than it is down here. And this has quite big implications for if you're making a prediction. So if you're making a prediction perhaps here, you are going to be really confident with that prediction because if you've got that non-constant scatter, it's really strong, the relationship at that particular point. However, if you are making a prediction perhaps over here, your prediction, in theory, it could be anywhere from up here to anywhere down here. That's actually quite a big range that it could have been. So in this case, I'll draw a little sad crying emoji. You're not as confident in your guess or your estimate in that situation. On to our second to last version of TARSOG, we're on over Outliers. And Outliers, just simply put, it's either a yes or a no. Well, that's it looks like a W. Yes or a no type answer. So either yes, there is an outlier, or no, there isn't. Whilst Outliers, it appears to be quite an easy point to understand, I just want to make a clarification. So for there to be an outlier, there are two things you're looking for. So number one, there needs to be a huge gap from other data points. And that one's really easy to identify. So we can see in the example we've got here, this one here, we've suggested there's an outlier. And the closest data point, that's a very big gap in there. You can fit a bus in there, to be honest. So that's a huge outlier, definitely one in this case. The second point we need to consider is the trend line. So a data point will only be an outlier if it's inconsistent with the trend you're observing. So for example, let's say this trend line here, I'm just sketching it over. Let's say we carried it on all the way up to here. We can see, well, there's physically a huge gap between those points. So that kind of meets the first criteria. But the trend line, that point, even though it's far away, it's actually pretty consistent with the trend that I was expecting. So that last point, it's consistent with the trend that I was expecting, makes me think it's not actually an outlier. Maybe it's just a really big value. Maybe that's like the Sonny Bill Williams of whatever that data set is representing. So you can see this one here, not an outlier, because it's consistent with the trend, even though it's really far away. This one here, yes, that is an outlier, because it has both elements. There's a huge gap from the next data point, and it's not consistent with the trend that I was expecting. The G in TARSOG, that stands for groupings, and groupings is another one, kind of like outliers. The answer is normally yes, you have a grouping, or no, you don't have a grouping. And I've got an example here, so we've got some groups, and what we can see is we can see 4 bits of data here, and we can see a huge kind of void, a huge gap kind of separating these points, and then finally we've got lots of data points up here. Now, groups, this might be a bit controversial, but when you get a data set surveying both, for example, males and females in relation to something, often you get groups because males tend to have a similar kind of characteristics, particularly if you're dealing with perhaps something like height, because males tend to be bigger, hence why they may be here, and you may have females who tend to be here. Perhaps you're measuring another characteristics. Just from my experience with my lovely wife and daughter, they tend to be a lot more organized. So perhaps all the females are sitting up there, and maybe me being a male, bit of a stereotype, perhaps I'm unorganized, and we're kind of sitting down here as a group. So often when you have males and females in groups, not all data, but some data, you'll see them grouped together based on the trends you perhaps see, and you'll see that big void there. So that wraps up TARSOG and how to apply it to analyze graphs. Every graph you get, you should be looking to do each point, and your answer ideally should be written in a sentence, perhaps supported with a bit of evidence from your graph. So that wraps up this video. Hopefully you learned a bit out of it. Thanks so much for watching. Now let's get into heaps of practice.